it's extremely hard to say that my code is faster than yours, and I kind of respect the courage of those people that can say that publicly, but I can't, even though I know that Ada is the fastest what-we URL parser in the world right now. But if you look into Ada's website, you won't see that claim.
Hello, welcome to the DevTools-fm podcast. This is a podcast about developer tools and the people who make them. I'm Andrew, and this is my co-host, Justin.
Hey, everyone. We're really excited to have Yagiz on the podcast today. So Yagiz is a Node.js technical steering committee member. You're also on the OpenJS Foundation. You're a voting member for that, correct? And you've done a lot of work on Node, specifically around the security. Is that like a big thing?
Performance. Yeah, mostly around performance. I added several different features as well, but I kind of refrain myself from adding new features.
Great. Cool. Well, we're really excited to talk to you about sort of your involvement in Node and some of the other work that you've done, performance related. But before we dive into that, is there anything else you'd like to tell our listeners about yourself?
Yeah, I'm an engineer with around 13 years of experience. I recently graduated from my master's, and when I moved to New York, that's how I actually started contributing to Node. I recently became a father, and that's Ada is the name of the URL parser of Node.js, and also my daughter's name. So yeah, that's the most important thing right now.
Yeah, I love it when programmers sneak their kids' names in. The one that I recently just learned about that blew my mind was the creator of MySQL. The things that he made, MySQL, MariaDB, and MaxDB, those are all the names of his children. So like he has his first kid was named My, so that's why it's named MySQL. And that sounds like a totally fake thing, but it's completely true.
Wow. That kind of reminds me about Linus Torvalds like sneaking his daughter's birth date into the actual Linux source code. So if you write timestamp of it, it reboots or something. I don't really remember.
Yeah. I thought you were going to say that Git was his daughter's name, and I was like, wow, that's terrible. Okay, so on to like the actual work that you do. So we touched on it a little bit, but what is your involvement with Node.js? How did you get started, and what drove you to become a contributing member to such a big project?
Yeah, so I'm a technical steering committee member. I founded and I'm still a member of the performance team of Node.js. Up until a month ago, I was the performance strategic initiative champion, meaning that I was the champion. I was the person responsible for improving Node.js's performance. It all started around a year and a half ago. So at the age of around 28, 29, I moved to New York with my wife. And I got into my master's. It was a computer science master's, and I have an undergrad in computer science as well. So it was going really smoothly. It was really easy. And one of the so I had to select a graduation project, and I didn't want to write a to-do list or a mobile app or a simple product that I can hack in a couple of days. And that's how I dive into the issues of Node.js. And I wanted to select a task that was worth my time and worth producing something so that my 2-3 months will be beneficial for others as well. And hence my experience, my work on URL parser started. That was the task. So James now from, again, Node.js TSC, opened an issue saying that they wanted to, he had an idea about rewriting the URL parser in WebAssembly, meaning like we can write it in C++ or Rust, and we can use WebAssembly in order to have a much more performant URL parser. So I spent around a month and a half just to start learning Rust and write the URL parser from scratch. I wrote not like 30-40% compliant parser, and then I compiled in the WebAssembly, and I realized that the performance is worse than what it is right now, meaning that when I dive into it, I realized that there are much more unperformance sides of using WebAssembly for synchronous string-related operations because of the communication, the serialization and deserialization of text encoder and text decoder. So then I spent another 2 months rewriting everything in JavaScript, and I realized that V8 sucks. I think I can say that publicly. And which made me realize that I need to dive into how V8 is implemented in order to optimize it. I spend a lot of time on it, and then I basically realized that I've reached the limit about writing a parser only in JavaScript language. Then I met a professor from University of Montreal called Daniel Lemire, which is also the author of SimJSON and SimUTF libraries, UTF libraries, and we started writing a URL parser. It took us around 6 months, and while doing that, I also contributed to several other things, but that's basically how it evolved and how I became a collaborator. And yeah, last year, November, I gave a talk about in NodeConf about how to write a fast and efficient URL parser for Node.js in JavaScript. So that was the turning point for me, I guess.
There's a lot to unpack there. Is there WASM in Node.js Core right now? I mean, are there other parts of Node.js that's using WASM?
But no other project inside Node Core uses WASM. But it's really easy to do that. But I don't like. There's no other contributor that writes WebAssembly and contributes to Node. But if someone did, then it would be extremely easy.
That's really cool. I didn't realize it was that far along to be used in Core like that. Something that you said though is like there's a boundary cost. Really, anytime you cross runtimes of like you have to copy, strings into memory or whatever, shuttle them around, and you definitely pay for that cost of assembly.
What folks like, what most people doesn't realize is that V8 does a really bad job at those encoding and decoding of strings, because V8 is written for browsers, not for server runtime. So they don't optimize for executing an encoding function 1,000,000 times on a single device. And if it's executed 1,000,000 times, they assume that they're using one of the good machines to browse internet. So it doesn't optimize it. And that was the bottleneck in text decoder and encoder.
So when you encounter situations like that, do people on the Node team contribute to V8 and try to debug those, or is it like kind of hard to get those issues fixed?
There are lots of people that contribute to V8, but they are mostly getting paid for it. I don't. So I looked into the code. I even championed one of the issues, but I didn't have any time to onboard myself on the sides of V8 while working on Node.js itself. But it's highly unlikely that a Node collaborator also contributes to V8. And vice versa. It's highly unlikely for a V8 developer to contribute to Node as well, unless they are getting paid by Microsoft or any other big corporations in order to fix a runtime or an operating system specific issue.
Yeah, that makes sense. They're definitely different code bases. They're doing very different things, so I can see how that would work. There's something that you said that I kind of want to dig into a little bit. You mentioned that you didn't think, or you had some problems with V8. I was just curious, like, what is it about V8 that was like non-ideal or hard to work with or whatever? Like, because I've only heard positive things generally, but then again, we haven't talked to a lot of people who've actually specifically done work in V8. So it's a really interesting take.
So all of my takes are like, all of my comments about V8 will be mostly about performance, not about the feature parity or any other thing, or as a product as well, because I don't have that much experience. I have specific experience on specific things that could have a huge impact on a wide range of users. So the problems that I tend to take is problems that are really hard, but when solved, they affect millions and billions of users. So crossing the boundaries between C++ and JavaScript is one of them. V8 has support called V8 Fast API, which means that instead of exposing an actual C++ function, you expose a fast path to that function called like a C function to it, which reduces calling that C++ function, but it has really extreme limitations. So like if a function that takes a parameter of string and it does some operations on it and returns a Boolean, for example, you can use that function. But if you have a function that takes a parameter of input, it allocates certain things and then returns a string, then you can't use it because you can't allocate new stuff in the fast API because they want to make it as simple as possible so that it doesn't get garbage collected and so on and so forth. So this limitation, I think it's okay. It makes sense. What doesn't make sense and makes it really hard to use fast API in V8 is if you have a string that concatenates by two other strings. Let's say you have a string called like process.pwd and then you append it with /node modules. Then this string becomes an unflattened, like not a flat string. And there is no way for you to use that parameter and trigger the V8 Fast API because V8 Fast API has a requirement of having one byte strings that needs to be like unflat strings, flat strings, sorry. So these kinds of things makes it really hard to find workarounds around it. And with a project with the size of Node, it kind of pushes us to find creative solutions that not always applicable to every problem.
Once again, we'd like to thank Raycast. Without our sponsors, devtools-fm wouldn't be possible. Raycast is an app for Mac that's like Spotlight, but with superpowers. Besides being able to do all the things that Spotlight and Alfred can do, it has a host of other features that are supported by community-made extensions. The extension API is super cool. It's actually built on top of React, and if you've ever written React, you can get into writing extensions super quickly. One cool extension that they came out with this week is actually one from the CEO Thomas and Pedro, who also works at the company. It's a quick way to turn on your camera and take a picture. It just shows the ability of Raycast to hook directly into your Mac and provide a unified interface for doing a whole bunch of things really quickly. You should also check out Raycast Pro. With Pro, you can take advantage of Raycast AI and do a whole bunch of really cool things on your computer, from translating text to summarizing text to having a full-blown conversation with the chatbot. You do a lot with it. Raycast Pro doesn't stop there, has a whole bunch of other features that'll get you up and going really quickly, such as syncing your profile across your devices. You want to advertise with DevTools-fm? Head over to devtools.fm/sponsors to apply. Do you want to not hear these ads? You can become a member on one of the various platforms that we offer memberships on. If you do get one of those memberships, make sure to join our Discord where we might not talk all that much, but if you're there, maybe we will. If you want more DevTools-fm in your inbox, head over to mail.devtools.fm to join the mailing list. And with that, let's get back to the episode. So is that why, like, of all things, like you chose to rebuild the URL parser? Was the URL parser like originally like an in-browser feature that because of performance implications, it just wasn't a good way to use V8?
So V8 doesn't have URL parser implementation in it. Chrome has it. This is mostly, I don't know, they're trying to make the V8 code base as small as possible and that only contains JavaScript implementation, language problems. It was previously implemented by James Snell, which was the TSC member that initially created the issue to replace URL parser, and he's also a really good friend of mine, so I can talk about it easily. So I forgot what the question was. Sorry.
The question was really just like why the URL parser first? Like, is I was getting at like maybe it was because of that intermingling of your code with V8. But what it sounds more like I'm just interested. Why would you choose that? Does it like touch a lot of different parts of Node.js and like a lot of performance could be gained out of it? Because like from my point of view, I don't parse URLs all that much in Node.js.
Yeah. So the issue is when you ask someone why you chose that task, and they will always say that like we assume that it will be easy. that was my reason. Like when you look at a URL parser, URL specification, and if it takes around like 10 minutes to read the actual specification. You say that, yeah, it's pretty straightforward because it's the implementation specification. So it actually tells you like there's a function that needs to take this, and then if the parameter starts with this character, then call this function and blah blah. So I assumed that it was easy, and I had the same expectations that everybody in the internet has, and URLs are extremely easy and it might be impactful. But when I dived into the specification itself, I realized that this is not the case. And even though you are not parsing a single URL at all, if you call fetch fetch right now, it calls URL maybe 4 times before returning a response. Or if you just say node index.js, it calls the URL parser 5 times just to parse the actual path of the index.js. So without knowing it, you are paying a lot of price, and we assume that it's extremely small. That's why nobody in the last decade worked on URL parsing in the whole world. And that was a place that I thought that we could shine, and we could write a library about it and affect millions and billions of users worldwide.
Yeah, that's cool. I wouldn't have assumed that the URL parser is called 5 times when just parsing your index file. And I can definitely resonate with thinking that a problem that's small will be easy. And you can attest it wasn't easy. It blew up into 3 different implementations across 3 different languages and spanning 8 months. So definitely a harder challenge.
Yeah.
What were some of the challenges that were involved in creating that?
So the creating and writing was not a challenge, but optimizing and writing the fastest one is. There are lots of edge cases in URL parsing parsers that you need to optimize for, and most of the URL parsers out in the industry used by really big corporations, they're not optimized. And I can give you a small example that while I was investigating and benchmarking, I realized that if you have a URL, let's say called https www.google.com, and if you have another URL that you have https www.google.com / that ends with a slash, it performs 2 times slower than the initial one on curl. And this is fixed, definitely, of course, but this shows the complexity of the state machine that was initially implemented, that initially written as a spec. Because whenever you see a slash specification, then it says that you need to go to the path state, which the path name of the URL contains. And path name has this initialization saying that, okay, if it starts with a slash and if it ends with this, if it has a state override and blah, blah, and those kinds of things, then it makes it really hard to optimize it. And not everybody, if you're not looking directly for that specific optimization, could see it. So we basically spent a lot of time finding those edge cases and also optimizing and finding how to speed up the happy paths in the URL parser. So for example, URL specification states that the URL, whenever you see a hashtag character, the URL will immediately go to the fragment state. But most of the usual cases, you don't ever see an hashtag. Because most URLs doesn't have fragments if you are working on Node.js. So we basically optimize it towards this, and it contains several different edge cases and things as well. And that's why initially we implemented a pretty straightforward parser, which is Ada URL version 1. Whenever we are seeing a component in the URL, let's say path name, we are allocating a new string. We are making it like a path name std string. Whenever we see a query, we set it to query, and then we were allocating lots of strings. And as a result, in Node.js, we were returning this whole array, which contains protocol, username, password, host, port, and those kinds of things in an array. And then we were converting that array to the properties of the URL class. And because there were lots of strings, and because V8 is extremely slow on serializing and deserializing strings, we written the whole implementation from scratch, spent 3 more months on it and came up with a solution that only returns the starting and ending indexes of each component instead of returning whole. So if you have a href of the URL, the whole input string, and if you have a protocol end, which is the index that returns the protocol, which HTTPS, and it's like 5. If you have a username end, which is equal to 5 again, this means that you don't have username, and so on and so forth, then you can actually have 7 unsigned integers and 1 std string to just cross the boundaries of C++ and JavaScript. And this actually resulted in maybe 70% improvement. So yeah, so there are some optimizations that we did specifically for the URL parser, and there are some optimizations that we did specifically for runtimes that have a cost of crossing the boundary, like Node.js. Yeah, I can really do this all night long because not everybody is interested about URL parsers, and I don't get to. My wife is kind of bored about me talking about URL parsers.
I can imagine. My fiance has similar gripes about me talking about coding. So before we get on to like talking more about perf, let's talk about some of the other features that you've implemented for Node.js. Have you implemented any other like non-perf related features or championed any?
Yeah, so a couple of months ago, I implemented the .m file parser. One of the TSC folks were interested in adding that because eventually we're thinking about adding a Node.json configuration file to the Node project so that instead of having this huge CLI with lots of arguments, you can just use that and go and use it. One of the challenges was that we needed to have a .m parser that supports Node options so that you can configure everything. Blah, blah. So this is what I did. Let me think. I recently added the navigator and broke lots of packages because I added hardware concurrency, but I didn't add user agent. So everybody was checking if type of navigator is not equal to undefined, then get me navigator.useragent, but user agent didn't exist. So yeah, this was pretty recent. Yeah, I think that's mostly it. I'm mostly like hold myself to not add any features because I don't like the discussion around adding those features. With benchmark, it's pretty easy. It's numeric value. I don't need to convince anybody. I just need to convince the compiler and the benchmarks. But apparently, even benchmarks has lots of drama around it, which made me question my life from time to time. I can say that.
Yeah. There's always the challenge of like, is the benchmark really representative of the performance as a whole? Is it like an artificial slice of something? We see that a lot in like framework comparisons.
So what I can say, let me tell a small thing about it. Like, in the case of URL parser, I care about the name that I put behind it, which is my daughter's name. And Daniel is a professor that has respect behind it. So we literally spent a couple of months on top of actually implementing things to just create the appropriate benchmarks. And we, like, for example, we crawled the 100,000 websites in the world and had a database of 1 million or 2 million URLs just to parse them as a data set. We crawled BBC because it's the most used website in the world and produced like a data set of BBC URLs. We created a virtual machine of Linux and we booted every path that a newly installed Linux has to create a file URL path and so on and so forth. So it's not about producing the fastest one, and it's about also creating the most reliable one. Because if someone comes and says that like your benchmark is wrong because if I put a slash at the end of the URL, then I can make your code like your code is extremely slow. So we didn't want to do that. So yeah, that's my take on the whole benchmark stuff that's happening all around the JavaScript ecosystem right now.
Yeah, I think typically, and correct me if I'm wrong with this, but it seems like something like URL parser, which is a little bit probably a little bit more deterministic, and like you can give it a finite defined set of inputs. It's just really about getting a large enough sampling size of inputs to really test performance. And some other things are more subjective. It's like, how fast does a page render? It's like, well, what do you mean? It's like, how fast is the first element on the page? How fast is it complete? How fast is it visually complete? What does it even mean? There's a lot of like subjective stuff that can start going into some of the benchmarks, which makes it harder to.
So most people don't realize that there's a magical part of benchmarking, even in problems like URL parsing, because with like SIMD, which is like single instruction, multiple data, you provide hardware-specific performance improvements, and on a different machine that doesn't have a Neon architecture, which is like Windows or any other device, then your code might be slower. So it's extremely hard to say that my code is faster than yours, and I kind of respect the courage of those people that can say that publicly. But I can't, even though I know that Ada is the fastest WhatWidget URL parser in the world right now. But if you look into Ada's website, you won't see that claim.
Yeah, I've followed some of the issues you're on with like the performance debates, and it seems rough where like there is less argument, but it's very easy for someone to come and going like, well, on my hardware, this is slow. And it's just like,
Yeah. And like if you have any file system operations, then it's extremely hard to benchmark it as well, because if you delete and add a file a million times, then you're not benchmarking your code, you're also benchmarking your hard disk, you're also benchmarking your operating system, and so on and so forth. So it's extremely hard.
Yeah, largely an unsolved problem. Like I like a simple thing that I want is just like, I want some way to test that my website is performant in the ways I know it was one day. It's just so hard to do that in today's modern computing world. Like you can't just say, oh, here's a farm of servers, go run performance tests. It's always going to be off by a little bit.
If you use performance counters, it's not. So if you use hardware performance counters that are specific, like there are some solutions that like M1, M2 machines are providing using Xcode, it will always give you the same amount of instruction count for the same operation. And then the question becomes like, how can I reduce this number from 12 to 11? And if you do that, it has direct implication on the execution time as well. So we are always comparing the execution times, but execution times might vary depending on the conditions, but the amount of instructions that gets run, it's not. But because we are benchmarking on Google Chrome, on top of a Node.js runtime, on top of another Go written bundler and blah, blah. So there's lots of things that you have to do, and it's nearly impossible to benchmark them with 100% confidence.
Yeah, it's hard. The more abstractions you have between what you're running and where you're expecting it to run, I think the more the sort of side effects you have to deal with and everything. So you've sort of been a pivotal part of the Node performance team. So how does that team? How do you decide what work should be done? Like who sort of makes that decision? What's the prioritization? How do those things come up?
So actually, before answering that, I'm going to answer who decides what needs to get implemented in Node.js. And there's an item in the onboarding document in the Node.js repository. I'm not really quite sure. I'm not going to quote it. I'm just going to say it out loud. Nobody decides what needs to get implemented. You are the owner of the project, and you are the owner of the thing that you are writing. So you define the agenda and the future of Node.js. The only part that Node.js TSC interferes is that if two different collaborators are not in line about adding a feature, about a change, or any other thing, then Node.js TSC comes in and makes that decision about which one is right and which one we should go with it. So the same applies to Node.js performance team as well. There isn't any specific agenda. There are some agenda for some people because we see that, I see that the internet and the other runtimes are performing really fast, and it's extremely easy to spot what Node.js lacks in. And this kind of gives me the motivation about where to look, because in order to find that optimization, I also need to spend a lot of time to look into that. So if a competitor, like competitor meaning other runtimes, do that, then they're actually helpful to me, because I'm always looking for challenges, big or small. And if someone comes in and says that, then that defines the agenda for me. There are some questions, there are some challenges that I can't contribute to because of lack of my skills or lack of my knowledge or lack of time. But putting them on the agenda and putting on the performance repository as an issue is also motivating for other engineers as well, because eventually we want to have a free and open source library, and we want it to be existing in the next 5 to 10 years. Hope that answered your question, though.
Yeah, absolutely. You'd mentioned competitors and that sort of inspiring performance, and I just did want to ask, how do you feel about some of the other runtimes that's come out? Do you feel like it's been helpful for the ecosystem as a whole, as you said, inspiring performance improvements? Have there been challenges that's come up from that? Like, I don't know, what's your perspective on it?
I think it's good to have opinions, not opinions. I think it's good to have different runtimes, different tools that does the same exact thing. But other runtimes being backed by VCs, where Node.js is backed by people and zero money and backed by an open source and non-profit organization, has its both caveats and advantages. So the question is, it's about philosophy and science. In philosophy, whenever you learn new things, you destroy the previous one and you replace that whole thing. But in science, we don't need to do that. We have the knowledge that we have, and then we put more information on top of it, and then we improve it and keep it going so that it improves over time. What I don't like about the current situation in here is that the code for Node.js is open, and anybody like me can come in and be a part of this organization and make decisions and rise to the TSC and have admin access to the Node.js organization. So I wish that they all contributed to Node.js, so we had much more performant runtime than all of the 3 runtime combined. But we don't. And that's the beauty of freedom and capitalism and whatever you call those kinds of things. I respect everybody's time, but the problem with the issue with the problem that they're trying to solve is that unless I'm a paid employee, I would never contribute to those runtimes. And people like me feel the same way, and that's a major blocker, and that's something that money can't money can buy through spending more money. I hope that's explained.
Yeah, no, that's fair. We've heard similar sort of feedback, about the tension between like Node being an open source, truly open, driven by a foundation sort of project versus, Dino and Bun definitely being VC backed organizations, and how like runtimes are actually hard to fit in the VC model. It's like ultimately, I think probably the logical thing that'll happen is if those runtimes live long enough, they'll end up in the same place where they're run by a foundation, because there's different companies that's bought into it and like want to, have a say in the future of the project versus, the obvious sort of, if we look at Dino's case, it's like they're providing cloud hosting stuff like a key value store and a queue system and, all these like add-ons, which of course are just like cloud products services they provide, but that's sort of separate from the project of the actual runtime. So I think that's in line with kind of what we've been hearing too.
Yeah. So that kind of applies to Node.js as well. So the only difference between those runtimes and what Node.js currently is that a single guy that's willing to do the work. And most of the time, that guy isn't paid. That guy, girl, they, them, whatever their pronouns are, they're not getting paid. And they're doing that work. Just recently, there's an open PR just to add local storage support, which is a key value storage support, but with the WinterCG compliance. There's another pull request that's open still to add FFI support to reduce the serialization and remove using V8 into the equation. So there are lots of things that are happening, and the other runtimes have the luxury to experiment with them and try to fit in different libraries and tools into the equation. And because of Node.js's size, Node.js moves slowly, but that doesn't mean that the technology that we use to develop and to maintain Node isn't old.
Yeah, I definitely understand the other side of it, where it's like you see this enormous project, like say I wanted to contribute to Webpack and like change something super foundational about it. I don't think from an outside perspective, I'd be like, I can go do that. And I can see the same thing with these runtimes. Like I'm sure Jared looked at Node and was like, I probably can't change that. Let's do a greenfield thing.
So if you go to Sean right now, which is a maintainer of Webpack, and if you say that like I have a problem with Webpack and we need to do this in order to advance Webpack, I'm 100% sure that because not because I know him personally, I communicated with him, but like he will be open about it. Unless you make and breaking changes that breaks millions of users and causes a lot more pain than what's getting to putting to the table, then that's okay. So the same applies for Node.js as well. All of those new runtime authors, they all contributed to Node.js, but it's hard to be it's hard to be a good engineer and also communicate really well, and that's the problem with the current ecosystem. If we all communicated really well, I think we could all be a part of this, be a part of a single runtime. It doesn't have to be Node.js or Dino or One or whatever. It will be a lot beneficial for everybody. I can say that. For example, like let me give you a real example about it. There is one of the Node.js collaborators recently rewrote the HTTP parser of Node.js in Rust. And it performs, I think, faster than the current implementation. But this means that we need to add Rust into our CI. And I recently became a member of the build working group. This means that I know what the devices are, and there are like 30 different machines in variety of in a range of places, in a range of compilers, and in a range of operating systems. And with knowing that, I know that it's extremely hard to add a Rust tool chain into our old equation because we can add it. It will take some time, but we can add it. What happens then? We need to upgrade that Rust chain to the next version. Then we need to do the whole thing again. So this means that somebody needs to do that work, and putting something to the project, writing it and contributing it is something else, and also maintaining for the next 10 years is also something else. So these are the challenges, and when you look at that way, rewriting everything from scratch and say like, fuck it, I'm just going to do what I do best, which is engineering. It might look easier, but it's the problem like 10% of the whole work takes the 90% of the time. That I don't know if I quoted correctly, but that's the whole problem that all runtimes currently have facing.
Yeah, I think that's like true of any software project. Ultimately, is like it always seems easier on the outside before you're in the details and you understand the trade-offs. It always seems easier on the outside because you just see like the happy path of like, oh yeah, this is the kind of thing that we need to implement, and there's all these trade-offs that you don't see. And then maintenance is hard, especially if you are running across many like hardware platforms, which I think is one of the things that probably people underestimate about projects like Node. So it's like, if you're going to run something like Node on, say, like a Raspberry Pi, for example, it's like, what has to happen there? And, because a lot of folks don't actually cross that boundary, they're working at higher levels of abstraction. They're like, oh, it'll just work, right? And it's like, well, no, actually somebody had to go do some work to make that happen.
Yeah, and like if you look at if you go to GitHub Node.js /build, you will see all of the different machines that we support. And if you go to GitHub Node.js /reliability, you will see all the flaky tests that we have. And with a project of Node.js size, which has around, I think, 5,000 tests right now, a single flaky test has a really huge implication to the whole project, and it drives away lots of contributors as well. So, and if you look at from a different perspective, let's forget about the maintenance stuff, and let's forget about adding new features. Let's dive into keeping and focusing on performance. Node.js is around maybe 100 to 200 different benchmarks. We have a dedicated machine just to run benchmarks. But we also have lots of regressions. BAM has lots of regressions. Dino has lots of regressions. So it's not about making things faster, but also making things faster while adding new features on top of it and not cause any regressions and effects on other platforms. And I can confidently say that I broke lots of machines and lots of users in the past year. Like I can give one of my best examples because I'm super happy that I had this chance to break so many machines at the same time. In one of the LTS releases in Node 18, we added a URL parser and everything was perfect. And I added an optimization for URL search params. Everything was perfect. And then somebody opened an issue saying that if you use port 0, it breaks because port 0 is falsy value. So I was basically checking for like if it's false. Just recently we had another issue saying that if you create a URL, if you set it to an invalid host, and then if you set a valid port number to that value, then the whole node process crashes. So these kinds of things happen. And what's really frightening and also exciting about it is that in Ada, the URL parser, has more than 1,000 tests. I single-handedly added maybe 100 different tests to web platform tests on URL to increase the coverage. Ada has a huge impact on the ecosystem, including curl and Boost. And Boost actually transformed Ada's tests into Boost, and they found 6 bugs in their URL parser by just porting our changes. And we have around maybe 80% of fuzzing test coverage because we're using GitHub OSS fuzz. But on top of everything, writing the fastest one, somehow there's a user that breaks your code. That's really exciting because it's like no one is safe. I can say that. And so I'm 31 years old. Before Node, I always worked with small startups. The most users that I had was around 10 million active users per month for a mobile app or something. I can easily say that having this option, having this experience to cause this much harm and also this much benefit, because Ada, on top of that, improved the performance of Node URL parsing by 400-500%. It's extremely unique experience that most engineers doesn't understand or grasp the idea about it. So this is why I'm contributing to Node.
Yeah. Like if you're in any other engineering discipline, causing a bug in like your bridge or something, that's bad. Like you don't want to brag about that. We're in this like special place.
Like, yeah, I know. But like I can say it right now because whenever that bug occurs, I fixed it in less than 24 hours. So that's why I can brag about it right now. But at that time, it was extremely stressing because 20 different people were opening issues, and we actually pin those issues in the GitHub repository just to make sure that like they don't open new issues. And no one in the Node core team say that like okay, Yagiz, you caused all of these issues. You need to fix it. No one even said one negative word to me. They were all happy and positive notes, and people were all okay with it. And I even broke Next.js. Like those things happen, and you don't get to find those kinds of people in anywhere else. And what I can also say about is that so I have around 170 commits in Node core right now. I have added around 100,000 lines to Node.js core, and I still do it free on my own time while I have a 4-month-old baby, because whenever I open a PR, there is a person smarter than me and more knowledgeable than me pointing out my mistakes or my code and try to help me without knowing me. And this is something that is really hard to get in life.
Yeah, I think that's an undercounted part of open source contributions, which is just like the sort of mentorship, the community learning aspect of it, which is tremendously valuable. So yeah, that's really awesome.
I learned that I'm going to be a father in NodeConf last year. And whenever I learned it, I went to the bar and I was like, oh my God, my hands are shaking, like, because I wanted to be a father. And I talked to James and Matteo, Colina, and they were like, okay, stop everything. We're going to buy you whiskey and we're going to celebrate this moment. And I knew them this was the first time, NodeConf was the first time that I met with them. And this was so valuable. And because like we were talking on the internet and about Node, but I think this is how friendships are made. And I had the chance to do it and to experience this with a project of this size.
Yeah.
Yeah, I think this is going to be a really motivational thing for Node.js, right?
I think that this is a really important thing to highlight, because over the course of the podcast, we've talked a lot about open source, and the challenges of open source is something that like comes up relatively continually, like how it's good to draw very clear boundaries, how you need to learn to say no, like the cost that open source can have on maintainers, etc. So we've talked a lot about that, but there's a reason why we spend so much time doing it. And, there's a real upside to this, the human connection that you get, the mentorship, how much you learn, this feeling of being a part of something larger, of, really making an impact that spreads and affects a lot of people. It's like there's some strong positive like cultural and social benefits to it too. And yeah, it's it's really great to highlight that for sure.
Definitely. A lot of people are really welcoming. I don't know any other open source projects except Node, because this is the most major project that I've contributed in my whole life. But it's extremely rewarding in terms of friendships and experiences.
So we've talked a little bit about open source here. We just talked about like the cultural and social good aspects, and I've alluded to some conversations we've had in the past about some of the downsides of open source. And then we've talked a little bit about the differences in JavaScript runtimes and how like Dino and Bun are VC based and Node is run by a foundation. The monetary aspects of that definitely impacts how people contribute and who wants to contribute. And like, there are some things there. Something that would be really interesting, I just would love to hear your opinion about it. If you have thoughts about funding in open source, or like, maybe what the future of this is, or like your own experiences with it, or anything that you want to share, because it's always interesting to talk to open source maintainers about money, because you spend a lot of time doing something for free, ostensibly.
So up until a month ago, I couldn't even open a GitHub sponsorship account because my visa in United States didn't allow me to earn money other than the company that I work for. And at that company, even though I use Node.js and maintain lots of microservices, it wasn't the reason that I contribute to Node.js. The problem that we are all seeing right now is that there are lots of things that people want to do. They want to help it publicly, but when the time comes, they don't do anything. And I think my recent example is a really like my recent experience is a really great example about this. So for people that doesn't know about it, let me summarize it. After the backslash about me declining a blog post about a comparison between runtimes because I'm not getting paid for it, I sent out a tweet and saying that if I open the GitHub sponsorship account, would you sponsor me? And it had a poll about like higher than $100, lower than 100, I will not pay, and then I'm not sure, kind of four solutions, for selections. And then time has passed and I got my green card just recently, and I opened the GitHub sponsorship account and I tweeted about it. And lots of my friends helped me spread the word. It has almost the same impression in terms of tweets in that in my latest post, even though 20% of that, like 15% of that 800 people, which corresponds to around like 200 people, said that they are going to pay, like they're going to sponsor me. Right now, I have around 39 sponsors on GitHub, and they're mostly small sponsors. So this kind of gives me the idea that this proves something. This means that people want fast things, but they're not okay with sponsoring them. They're not okay with paying for them, because if you sponsor you for $100, it will all benefit you, but it will also benefit thousands of people. And then this kind of gives you the question about, if it's going to affect a lot of more people, then why am I the one that are paying? Then it becomes a chicken and the egg problem right now, and then no one does it, and then we end up with the same situation that we want to avoid. So it's extremely hard to monetize it. A couple of companies reached out to me personally, wanted to find a solution for me to do what I do full time, but under their company. I didn't want to do it for full time because this is too much pressure. I can, if I do it as a hobby, then it's something else. If it's my full-time job to find performance improvements, I think I can do it for 3-6 months. But after then, well, my lack of creativity will kick in, and I'm afraid I can't find some optimizations. So the question is, there are companies that are willing to pay for it, but they want to correlate this work with their work, and there are some companies, there are products that fit into those equation, but it's highly unlikely a senior engineer will leave their full-time job and do this as a whole thing. So then it becomes a problem. It becomes the current situation that Node.js is in. There are companies like IBM, Igalia, or Red Hat or Google that have dedicated people in both Node.js TSC or Node.js core team that carry their own agenda, for example, including Windows ARM support and making it to tier 1, or improving AEX, SmartOS, operating system support, blah, blah. If you don't fit into those equations, it's extremely hard to find a reason for companies to sponsor you. And then the problem becomes, am I a good developer relations? Like, am I a good DevRel or not? If I'm a good DevRel, then I tweet and then I reach out to more people, and maybe 10 people give me $10 per month.
Yeah, it's a weird system we live with today. Literally just yesterday, last night, I was looking at my GitHub sponsors and I noticed I actually had to, and I have a total of $7 a month for all the work that I've done in open source. So it's definitely like it's a very weird feeling. It's like somebody kind of cares, but like not really, like not enough for me to like actually focus on this thing.
Yeah. The good thing is there are people that actually. So what I'm told at my GitHub sponsorship page was that if you sponsor me, then I will prioritize what you want me to optimize, which will be beneficial because I like optimizations, and this will make your agenda heard. And there are some people started doing it as well, but it's not a good amount that makes it a full-time job, or at least a part-time job to do it. It's a good thing to have some sort of money, but yeah. it's not feasible in the long run. But yeah, we will see, I guess.
Yeah, I think there is this thing. There's like a threshold where it's like, someone pays you, you spend like 8 hours doing something, and somebody gives you like $2, for like, oh, thanks for doing this thing, and you're like, honestly, like I appreciate the sentiment. I appreciate you doing something, but like maybe you should have just not.
Okay, one last question before we move on to tooltips. This one isn't on the doc, but I have been enjoying asking it to all the guests that come on. So, what is your spiciest dev take? Feel free to take a minute to collect your thoughts.
URLs are free are the most recent one that I had my eye twitched. Performance, Node.js is slow is something that extremely twitches my eye because it isn't. It's a solution that particularly fits in a particular problem. And if you don't fit into that equation, it's slow. But Go is also slow, or Rust is also slow as well. My most recent, not my most recent, but my most impactful thing is that a year ago, I didn't know any C++ at all. I wrote C++ maybe 10 years ago in college, but I didn't use anything. So my 2023 New Year's goal was to write C++, and that's why I wrote Ada. And before that, in 2022, it was Rust, and that's why I learned Rust and did it. And this whole Rust and C++ takeaway, like Rust is better than C++ and so on and so forth, those kinds of things, and everybody is using Rust to write the new stuff, is extremely annoying to me because Rust provides certain things and it's really good at the ownership about memory safety and those kinds of things. But in terms of if you care about performance, writing something, if you start a new project, you can write it 2 times the amount of time that it takes in C++ in Rust. So it will be slower if you write in Rust, but you will always reach a performance limit. But if you write a C++ function, like C++ project, which when I first wrote the Ada URL parser, it was like 0.1. It was 10 times slower than curl because it was really easy to make mistakes. But if you don't make mistakes, if it's limiting, then it's extremely hard to optimize and learn what those errors are. And this is the whole C++ Rust thing. And we, most recent one is that about this. So we added a C API to Ada, and we started adding libraries. We have a Python version, which is maybe 2-3 times faster than Python's default URL parser. We have a Go one, which is extremely fast. We have a Rust one, Rust version of Ada, which uses C++ code, but through C API, is 3 times or 6 times faster than Servo's URL. And then, so I released the Rust version, and then I opened the PR to one of the large libraries to replace their own one with Ada's version. It was a lot faster, and I had the benchmark to prove it. But it was the main reason that one of the maintainers responded to me and said that the main reason that we are writing Rust is because not because of speed, but because of memory safety. But up until that point, that project was the fast blah blah solution for Rust. And so all Rust developers use speed and safety and those kinds of things as a way to market their programming language. But it's really easy to make mistakes in Rust as well. But it's extremely hard to optimize Rust code.
It's a good spicy take. My first tooltip of the week is a doozy. This just popped up on my feed. This guy wrote it's so hard to explain. He wrote an entire game engine in TypeScript types. So you can right here in this blog post, he has Flappy Bird coded with TypeScript types. And then he has I think I'm getting this right, a Rust compiler that compiles the types into TYVM, which is his bytecode that runs the games. And then he wrote a Zig runtime to run that output, and that runs the game. I haven't read too much into this, but just the amount of magic that's going on here is absolutely crazy. It takes one of my favorite talks that I ever saw at TypeScript Conf, and really one of my favorite talks ever is Josh Goldberg, guest of the podcast, coded tic-tac-toe and a bunch of other things in the type system. With this, you could actually play that and have like a game. So I think I just love the weird wizardry that's going on in the TypeScript type land. And I'm sure people in real statically typed languages are guffawing over all this.
Yeah, I think in the background it uses the OXC parser, but it's pure magic to me just to like read it and understand it.
It seems like, so you have to have all this extra tooling for the game to actually work, right? So it's just like you're picking a poor DSL for writing games at this point. Like, super.
The question was not should we, it was can we, and we have answered that with yes, we can.
Yes, we can.
Yeah. So if you're looking for some just crazy weird coding to delve into over the weekend, go check out TYVM by Zach Overflow. Seems like he has a bunch of cool posts on this website. Next up, we have AudioFlare.
Yeah. So Cloudflare had released this AI like computational product where you can sort of like do some edge compute and run models on the edge or whatever, which was really interesting. AudioFlare is an open source project that is sort of like a one-stop shop AI audio playground using Cloudflare's AI workers. So it basically lets you like transcribe things, do some audio analysis, like whatever. But it's kind of a pretty interesting use case of Cloudflare's AI workers. So if you're sort of interested in what those are and how they work and what kinds of things you can do with them, I think this project is definitely one to check out. It's pretty interesting.
Like I don't know you guys, but like I'm a huge fan of Cloudflare and the products they're developing. It compared to how AWS's UI, I think Cloudflare is a lot better, and how they are progressing towards a stable product, like a small step at a time. It's fascinating.
Well, so Andrew and I have talked a little bit about like productionizing AI models and like what it would look like to build a product on some of these. And like it's non-trivial in most cases, to like start doing something like to start productionizing something. But like these AI workers are really, really interesting for a narrow set of cases. It has some limitations and restrictions, but for some narrow set of cases, this is like a really viable way to take a lot of the AI models or the ML models that has been released recently, especially the smaller ones, and turn that into some sort of feature or product or whatever. So definitely don't sleep on this. I think, yeah, we love Cloudflare. I love Cloudflare. They're doing a lot of really interesting work. And this has been kind of cool just to see more productionization of ML functionality.
Yeah. Except yesterday when they took down the whole internet, but different issue.
What I don't still understand about Cloudflare is that, since we're talking about it, how pages right now, Cloudflare workers still have a limitation of 10 megabytes of deployment. It's like, okay, I want to deploy my blog to it, but it's not possible.
Yeah, I got some gripes with pages too, and I think pages and workers are a little bit redundant, but I think they're also trying to work on that to unify it. But anyway.
So I posted this. So this is a really common problem with parents, and I wanted to mention it. So I have this really fancy camera that we use to make sure Ada is sleeping and like as a baby monitor. And a couple of weeks ago, we heard noise coming from the actual device. And we were like, oh my God, how is this even possible? It's 2023. How would are they not encrypting the communication between the device and the transmitter itself? And apparently they don't. There's a protocol called, I forgot the name. So instead of encrypting the actual communication, the baby monitors that they change the frequency that they're transmitting in. So from time to time, they change the frequency. So it makes it really hard to keep track of the frequencies and to have a consistent listening of the whole session. But if you have a really huge spectrum device and if you listen to a huge spectrum of wide range of frequency, audio frequency, then the radio frequency, then it's extremely easy. So I was looking for solutions to find a hardware-only camera that is not open to internet. And I was using a Dream router by Ubiquiti, and I found this. Basically, if you have an internet and if you have a Dream router, you can add like a 1 terabyte of micro SD into the actual router that you have in home. And if you have a wired camera, which is around like $100 in UI.com, which is a lot cheaper than what I paid for that shitty baby cam, you can have a really good security and have a camera.
Yeah, I've heard nothing but good things about Unify. This is like the final level of home automation is getting a rack and just loading it up with a bunch of their products.
Yeah, but I don't have the rack one. You can still have like a Dream router, which is like a $200 router solution, and do the same thing as well.
Cool. Yeah, that's awesome.
But yeah, that's the dream, to have a rack in house and I can deploy my own stuff and do anything.
Yeah, someday I'll look back and go, wow, how far I've come from my Raspberry Pi startings. Okay, so this one also just popped up on my feed today. This is a Vite replacement written in Rust, because we all know that Rust is the fastest language on the planet. This is a project that you just had to know was coming next. Like, if RSPack exists, something like this must exist also. I'm just excited for really fast builds, and I hope we have a nice community around it. So yeah, if you're looking for a Vite replacement that's even faster for some reason, I'd check out Farm. It looks like it's in the very early beginnings of the project stage, but it does cool things like support all of the plugins that currently exist for Vite and for Rollup. So that's a pretty big difference between other Rust-based tooling in the space.
Yeah, I think the most selling part of this whole product is that supports both Rust and JavaScript plugins, because it's extremely hard to execute JavaScript and have a JavaScript plugins in a Rust project. So if they found out the solution, then I'm all up for reading the code.
It's really interesting. So the Vite team they're writing a rollup, like they're rewriting rollup in Rust. And I wonder like what part of Farm, like what Farm is actually doing. Is it also doing that, or is it like replacing the ES build part, or like the glue between the things? I don't know. That's interesting.
Yeah.
And like I don't know you guys, but like whenever I see a project like that, I basically go to GitHub page and see what the collaborators are and just calculate the bust factor of the project before I make a decision about it.
Yeah. Well, we'll see where this one goes. There's a lot of competition in the space today, but as you said, Yagiz, the saddest thing I think about of the new way of JavaScript tooling is how it's all just like no more plugins anymore, and that was like the core manifesto of the last generation. So I hope we start to see tools where like they care about plugins, or at least giving us the ability to make our builds slower.
Yeah, true. And also, I wish to have new products that instead of having benchmarks for 1,000 React components, they actually rendered an actual like real world application. That like maybe Calcom, like if I was the maintainer of this project, maybe this is like a good call out to them. I would probably go and replace Calcom's build with their solution and just share the solution instead of rendering 1,000 React components at the same time.
An interesting example came up on my feed recently. An engineer at Discord moved them from Webpack to RSPack, and like they saw like a 70% increase in like speed overall. So definitely some interesting examples out there. I'm very keen on RSPack. I want to integrate that at Descript, but haven't been able to yet.
They're doing a really great work. I've been in touch with them before it was public, and it's really good to see a solution that's 100% compatible with Webpack and provide a faster solution.
Yeah, and it's amazing how far that promise goes. Like our Webpack config is by no means simple. Like I'm using types. I have custom loaders, I have custom plugins, and I was able to get the types to pass just by replacing Webpack with RSPack. So it's already a very, very way along. Okay, up next we have Silver Sky from PR's Guitars.
So Paul Reed Seed is one of the companies that provide the best guitars in the world after Fender, and I forgot the other company. So this is a signature series by John Mayer. So this is actually signed by, not signed by, but like it's electronically signed by John Mayer, and it's a really great resonance. And it's I recently got it last year, I guess. And if you're looking for good guitar with a medium price range, then I'm 100% sure that this is the best guitar that you can get if you care about sounds that are similar to John Mayer.
I'm not looking for a guitar myself, but it is quite a beautiful guitar.
Yeah. So the board is a Stratocaster, which is a Fender's signature. But yeah. So basically, instead of going for Fender, for like John Mayer, instead of going to Fender, he went to PRS and got the signature series. So there's two different versions. One of them is Silver Sky, and one of them is SE Silver Sky, which is like a cheaper version, I guess.
That's awesome. I need to pick up guitar again. Been too long.
And last up, we have Winter.js from Wasmer.
Yeah. So this is a really interesting project. And there seems to be like, so there's a Winter CG, which you'd mentioned that earlier. I think it's just like, I'm just keeping my eye on this like compatibility, the WASM compatibility story. Winter is sort of a JavaScript service worker server written in Rust, I guess. And I don't know, it's a part of the overall like this like JavaScript executable. You can almost think of it like the Cloudflare execution model of like we're deploying you're deploying like a serverless function or whatever in that model, like it's a service worker, sort of that same API. So, I mean, this is from Wasmer. Well, this is like related in that sphere, but I don't know. It's sort of interesting. This is using SpiderMonkey under the hood. It's kind of a cool project. I haven't really dug into it too much, but yeah, I don't know.
So this post is one of my another spiciest dev takes. If you go to the header, you will like just read the description. The most performant JavaScript service workers thanks to Rust and SpiderMonkey. And it says most performant. And if you search for benchmark or performant or fast or speed, you won't see any references to it. And it's like, after I read this, and the whole point is that, so I have some folks and friends that actually work and contribute to Winter CG, and having a name similar to Winter CG, but Winter GS is like, it's a marketing take that I wouldn't do.
Yeah, they call out Winter CG in the post or whatever, and I actually thought they were related. I didn't actually realize they weren't related, but I guess
I think that's the whole point about selecting a name similar to Winter CG. And this is like, I didn't even talk about the technology right now. I'm just talking about the marketing page, because that defines the future of any technology. Like whoever writes it and puts their name on this article, they're going to define the future of this technology, not me, not everybody else. So.
Yeah, you got to back up those claims if you're saying you're the fastest. Okay, that wraps it up for Tooltips this week. Thanks for coming on, Yagiz. This was a very fun episode delving into how Node.js works and how you've affected its roadmap. So thanks for coming on and talking about it.
Thank you, and thank you for hosting me as well. It's been a privilege talking to you and sharing my take about all of the things happening in the world.
Yeah, thanks so much. It's really interesting to hear all the like deep performance things in Node, especially around the URL parser. So that's pretty cool.